Alright guys, this last section of chapter 12 is over congruent and similar solids. So what we're doing is we're kind of comparing the different shapes, looking at surface area and volume to see if they are in fact congruent or if they are similar. Now remember, congruent means same size, same shape. Similar means same shape, different size. So in accordance with that, your ratio of your corresponding parts has to be the same throughout. So here the ratio of your radii have to be the same as the ratio of the height and slant height. So you're given two different heights here. And so you got to be real careful when you're comparing these because if you get in too big of a hurry, you can get thrown off track pretty fast. All right, so we're going to determine if each pair of solid is similar, congruent, or neither. And if they are similar or congruent, write the scale factor of the solids from left to right. So we're going to write this one first and then this one second. Okay, SF stands for scale factor. So what we're looking at, we can do volume or surface area, whatever we want to compare them, or just look at the dimensions, basically. Well, here we have a radius of 5 for both of them. This is your actual height, which is 12. Now, remember that this creates a right triangle, and this is a Pythagorean triple, a 5, 12, and a 13. So the slant height of this one is 13. Well, that happens to be the slant height of this cone, giving it a height that would be 12. Okay, so between these two, because their dimensions are the same, they have to be congruent. So they are congruent, and the scale factor 1 to 1. Okay, or the scale factor is 1 because they would reduce down. 13 is to 13 as 1 is to 1. 12 is to 12 as 1 is to 1, and so on. All right, looking at the cylinder. All right, obviously these are different. Here, this is kind of, okay, this is the radius, that's 10. This is the diameter, that's 10. Now, if the diameter's 10, then the radius is going to be 5. Okay? The height is 7. So we've got a radius, which is 10, and a radius, which is 5. A height which is 14 and a height which is 7. This is the height of this cylinder. It's the distance between the bases. So you can see just by comparing those numbers, 10 is to 5 as 14 is to 7, that the larger one has been doubled. Okay, the smaller one has been doubled to get the larger size. So these would be similar, and the scale factor would be 2 to 1, or you just put 2. Okay, the left to the right, so we're going bigger to smaller on this one. All right, let's take a look at the pyramids. Looking here, you've got a square base with dimensions that are 12. This one you've got a square base with dimensions that are 8, so obviously not congruent, so let's see if they are similar. This pyramid has a height of 15. All right, so, and this one has a height of 10. So what we can do is write a ratio and see if they are proportionate. So the length of the base is to the length of the base. 12 is to 8, as the height is to the height. 15 is to 10. This multiplies to give you 120. And 8 times 15 multiplies to give you 120. So the ratios of the base and the height are corresponding, or are similar. So this would be similar. And the scale factor, we would need to reduce it down. We could go 12 to 8, and that reduces down to 3 to 2. I take out the common factor of 4. 4 comes out of 12, you've got 3. 4 comes out of 8, you have 2. So the scale factor is 3 to 2. All right, number 4. You've got a cube because the length, width, and height are all the same. Length, width, height are all the same. Now, because they're cubes, all cubes are proportionate because all their dimensions have to be increased or decreased by the same amount, or you no longer have a cube. So, and it's the same thing with spheres. So all spheres are proportionate. They're all similar and that just has to do with because of its shape. So these are definitely similar. They are not congruent. And the ratio from left to right is 2 to 5, and that's done. All right. Now, prism, a little different situation. We got to double check the length, width, and height. Length, width, and height. They all have to be proportionate. So the length down here is 1 to 3. Let's see if that equals the width here, 2 to 6. Let's see if that equals the ratio of the height, 3 to 9. Well, both of these reduce down to 1/3. They are all equal. So yes, it is similar. And the scale factor is 1 to 3. All right, and then looking at the sphere. All spheres, I said, are similar, and I think I took some of these out because they were repetitive, but they must have been the ones that weren't similar or congruent, so it's possible for that to happen. All right, so here we have a diameter of 3.5. I'm sorry, not a diameter, a radius. Here we have a diameter of 4.2, so our radius would be 2.1. Now, I said all spheres are proportionate because they're like a circle. All circles are proportionate. It's because of their shape. A circle is a circle because of its shape. Triangles have different shapes. Circles only have one. They just have a bigger size than others. So this has to be similar. And then your scale factor would be 3.5 to 2.1. But what I want to do is double check and see if that can be reduced down, which it definitely can. 3.5 divided by 2.1. If you put that in your calculator and hit math, and you use fraction, enter, you're going to get 5 to 3, that ratio, and that's how it should be written, 5 to 3, to be written with whole numbers instead of decimals. Okay, now, some other things you're going to be doing with similar solids is comparing surface area and volume, as well as using scale factors, so that's what we're going to practice on right here. It says, find to the following using the pair of similar cylinders for cylinder 1 and 2. Show your work. So now your surface area 1, and this would be complete surface area. So surface area, the formula is 2 pi r times your height. This is your circumference times your height for lateral, plus the 2 bases, and the bases are pi r squared. And I'm writing that down and you can't see it, I apologize. So here's your formula right here. Alrighty then, so we've got that there. I'm going to plug those numbers in, 3 for my radius, 8 for my height. So this would be for cylinder 1, 2 pi 3 8 plus 2 pi 3 squared. And plug that into my calculator directly. 2 pi and 3 times 8, I'm just going to go ahead and put 24. I'm lazy. Plus 2 pi, and then 3 squared is 9. I'm going to just plug that in. There we go. 207.3. 207.3 in the centimeters, and it'd be squared because we're talking area. Surface area of cylinder 2, we've got 2 pi 6 times 16 plus 2 pi 6 squared. So 2 pi 6 times 16, what is that, 96, plus 2 pi 36, 829.4. 829.4 centimeters squared. All right, now we're going to find the volume of these. Okay, the volume is going to be base times height. Now remember that the base is the area of a circle. So that's actually what we're looking at for our base is pi r squared. Let me move that arrow out of the way. It's bugging me. Okay, so we've got pi r squared times the height. And on this one, we've got pi r squared times the height. So we'll put both of those in. Pi, this is 3 squared is 9, and 9 times 8 is 72. So that would be 226.2 centimeters cubed, because we're talking volume, so it's cubic. All right, the next one, pi 36, that's 6 squared, and I'm just going to put times 16 because I can't do that one in my head. All right, so you've got 1809.6 centimeters cubed. All right, now, scale factor of cylinder 1 to cylinder 2. All right, scale factor. Let's go ahead and compare. What we've done is the radius, if you notice, it's been doubled. The height, 8 to 16, has been doubled. So from cylinder 1 to cylinder 2, you could say 3 to 6, which reduces down 1 to 2. Be sure you simplify those. The ratio of surface areas of cylinder 1 to 2. All right, we have cylinder 1 is 207.3 to 829.4. Now we rounded those, so I don't know if those can be simplified anymore. I'm going to put those in the calculator just to see, but we'll probably end up having to leave it just like that. 0.3. Oh, actually, we don't need to do that. We've got an easier way to do it, because area is two-dimensional, right? So all we got to do is take the straight line, the one-dimensional figures, and square them. So it's 1 to 4. Let's double check that and see if 829 is 4 times greater than 207.3. If I take 829.4 and divide it by 207.3, looky there, I almost get a perfect 4. It goes out to the 4th decimal place before you've got anything. So pretty darn good. So we're going to write our ratio 1 to 4. The ratio of the volumes. Now, volume's three-dimensional. So what we do is we'll take our ratio of our one-dimensionals to the third power. So this would be 1 to 8, which is 1 cubed. Let me do that again. 1 cubed to 2 cubed. That's how I got my answer. This one was 1 squared to 2 squared. Okay, this is a huge topic that students continually miss. And if you're going, well, whoa, how come it's 8 times greater? Well, looky here at the volumes, 226 and 1809. Divide those and see if you don't get 8. So 1809.6 divided by 226.2, and oh, looky there, it's a perfect 8. Woo! All right, because you're going 3 directions when it comes to volume, you're going 2 directions when it comes to area, you're going 1 direction when it comes to just comparing the different lengths. All right, that is what similar solids is all about, and I'm done.